Enhancing Kubernetes Traffic Management with Topology-Aware Routing. This podcast is brought to you by Business Compass LLC. We are an Amazon Web Services advanced consulting partner. We build and migrate workloads to Amazon Cloud. Our website is businesscompassllc.com. Our phone number is 973-638-2228. Our email address is contact@businesscompassllc.us. The challenge of cross-zone traffic in Kubernetes. Applications often span multiple zones in a Kubernetes cluster to ensure high availability and fault tolerance. However, this can lead to inefficient cross-zone traffic, increasing latency and higher costs. This challenge necessitates a solution that optimizes traffic flow within the cluster while maintaining reliability and performance. Introducing Topology-Aware Routing, TAR, a Kubernetes solution. Topology-Aware Routing, TAR, is a feature in Kubernetes that addresses the challenge of cross-zone traffic. TAR enhances traffic routing by leveraging the cluster's topology, ensuring pods handle requests in the same zone whenever possible. This reduces cross-zone data transfer, lowering costs and improving performance. Setting up the demo environment, applications and services. To demonstrate the benefits of TAR, we'll set up a demo environment with multiple applications and services distributed across different zones. Here's an outline of our setup. Create a Kubernetes cluster. Ensure the cluster spans various zones. Deploy applications. Deploy two sample applications, App 1 and App 2, across the zones. Expose services. Expose these applications using standard Kubernetes services. Create a multi-zone Kubernetes cluster. Example with GKE G-Cloud Container Clusters. Create demo cluster num nodes equals 3 zone equals us central 1A, additional zones equals us central 1B, us central 1C. Deploy App 1 and App 2. Kubectl apply f app 1 deployment.yaml. Kubectl apply f app 2 deployment.yaml. Expose services. Kubectl expose deployment app 1 type equals load balancer name equals app 1 service. Kubectl expose deployment app 2 type equals load balancer name equals app 2 service. Observing random traffic distribution with standard services. Initially, traffic distribution is random without TR, and pods handle requests in any zone, often resulting in cross-zone traffic. We can observe this behavior by generating traffic and monitoring the network flow. Generate traffic to App 1 and App 2 services. Curl http://app1 service IP greater than. Curl http://app2 service IP greater than. Using monitoring tools like Prometheus and Grafana, we can visualize the traffic distribution and identify the extent of cross-zone traffic. Enabling topology-aware routing for optimized traffic flow. Enabling TAR in Kubernetes requires modifying the service configuration to include topology-aware routing settings. This can be done by updating the service manifest files. app1service.yaml. API version, v1. Kind, service. Metadata. Name, app1 service. Spec, selector. App 1. Ports. Protocol, TCP. Port, 80. Target port, 8080. Topology keys. Kubernetes.io/hostname. Topology.kubernetes.io/zone. Apply the updated service configuration. Kubectl apply f-app1 service.yaml. Kubectl apply f-app2 service.yaml. Validating zone-aware traffic routing with TAR. After enabling TAR, we can validate that the traffic is routed within the same zone. Generate traffic again and monitor the network flow to see the difference in traffic distribution. Generate traffic to App 1 and App 2 services. Curl http://app1 service IP greater than. Curl http://app2 service IP greater than. Using monitoring tools, we should observe a significant reduction in cross-zone traffic, indicating that pods are now handling requests in the same zone. Scenario: traffic routing with a single app2 container. To further illustrate the benefits of TAR, consider a scenario where app2 has only one pod in a specific zone. With TAR enabled, requests to app2 will be routed to the available pod, ensuring optimal traffic flow without unnecessary cross-zone data transfer. Scaled down app2 to a single pod in a specific zone. Kubectl scale deployment app2 replicas equals 1. Kubectl get pods O wide. Conclusion: the benefits of topology-aware routing. Topology-aware routing (TAR) is a powerful feature in Kubernetes that optimizes traffic flow within a cluster by leveraging zone-aware routing. By reducing cross-zone traffic, TAR enhances application performance and lowers costs, making it an essential tool for managing distributed applications in Kubernetes. Thank you for listening to our podcast. Please share this podcast, visit our website, and follow our social media links.